So this next example is example EX27 in my Java 8 folder in my live lessons GitHub repository. And it's a very interesting example that shows how to apply timeouts that are part of the Java Completable Futures framework, beginning with Java 9. Java 8 did not support these features. Java 9 does. Mercifully, Android now supports Java 11, so you can use these features in Android. And of course, Java is now up to Java 18. And I take it back. I think it's up to Java 19. Not many IDEs support Java 19 yet, but the release is out there. So you can use that with newer versions of modern Java. So the particular example is kind of a fun little mock-up of some sort of a web service style program. And it's going to compute the price between, say, New York to London or London to New York. And it's also going to figure out the exchange rate in dollars to pounds or pounds to dollars. And then it's going to take those two computations that will run asynchronously and then use them to figure out the price for this leg of the trip. And the way it's written is that it's got some random sleep times in it. So sometimes the computations take a while to run. And if they take too long to run, then they're going to time out. And we're going to do different things when timeouts occur than we do when timeouts don't occur. So a couple things to show here as far as fields go. We have this field called default rate, which is the default exchange rate if a timeout occurs. And I think it's doing pounds to dollars. It's pretty funny because when I wrote this program a couple of years ago, it was like, $2 to the pound. And then as a result lately of Great Britain's prime minister fiasco, I think the dollars and pounds are roughly equivalent. So the default rate now is probably pretty accurate. And if you look at monetary exchanges, we're going to run the test 5 iterations. You'll see when we run it what that does. So the main method starts up an instance of EX27 and then runs the run method. Here's the run method. As you can see, it iterates for S max iteration times, which in our case is 5. And what it does each time is it calls this method called find best price. And we'll look at that in a second. And that method is going to run in a background thread. So it's going to find the best price from London to New York City. And let's just go see what that does. It's a very silly little method that could easily be implemented lots of better ways by looking stuff up in a database and so on. But it delays for a random amount of time, and then it returns the value. The main point here is to delay for a random amount of time. So it delays for a time between a half a second and 4.5 seconds. So this will not always run the same amount of time each time. And that's important for timeouts. The next thing we do is we go ahead and start up another asynchronous computation. And this time we're going to query for the exchange rate between US dollars and British pounds. And again, this is just a somewhat fabricated method that sleeps for a random amount of time and returns 1.2 just for kicks, if the call finishes within the timeout range. And what we say here is we say, if this computation doesn't complete after 2 seconds, use the default rate as opposed to what would have been returned from this call to the query exchange rate for method. So if all goes well, we get back the exchange rate. If things time out, we're going to go with the default rate. So now we've got 2 completable futures to 2 asynchronously running computations. And what we're going to do now is we're going to use one of those completion stage methods that waits for 2 previous stages to finish before it does its thing, before it runs its action. And so what we say here is we say, when the best price completable future and the exchange rate future complete, then combine them by calling the convert method. And the convert method basically takes the price and the rate and it multiplies them together. So it converts them. If all goes well, we'll get the converted rate. However, if the whole processing of asynchronous computations takes longer than 3 seconds, then a timeout exception will be thrown. And when that occurs, we're going to go ahead and determine what happens. We say if we didn't get an exception, we print out the price, which will be in the converted rate for pounds. Otherwise, if the amount was null, that means that we got an exception. So we print out the reason for the exception. And then we swallow the exception so we don't have the program fall off the top of the stack and blow up. And then we call join, the one and only call to join in this loop to block until all the asynchronous processing completes. Let's go ahead and run the program and see what's going on. It's really cool. So you can see iteration 0, we got a timeout exception. Iteration 1, it gave us some results that were actually sensible. And you can see that we get different results. So if we don't get the, let's see, if we get a certain exception, then we're going to go ahead and get one multiple. If we don't get an exception, we're going to get a different multiple. So in this case, you can see that we got a different result here for this iteration than we did for these iterations. And that's because we got a timeout here. And there's two different types of timeouts. There's timeouts on the rate conversion, and there's also the overall timeout for the entire chunk of code. And so depending on what we're dealing with, we get one or the other timeouts, and that affects the results here. So this illustrates in a very nice, succinct way how you can handle timeouts using the completion stage methods that were added in modern Java, in Java 9 and beyond. And this is a really cool example. There were ways to do something like this in Java 8, but it required a lot of extra programming on your part. And so having this feature built into the Completable Futures framework makes it very much more powerful.